Great. Hello, everyone. Welcome to the fifth FOC virtual meetup in 2025. We've got three presenters today, and Marek, who's going to be showing us some kind of build system, something or other. Tom, who's going to be showing us a reactive notebook with a lot of buzzwords. And Achille, who's going to be showing us an interesting Chrome extension. So yeah, without further ado, Marek, take it away.
Sure. Can you try to pin me somehow to the presentation? I'm not sure if I am.
Yes, I absolutely can do that. There you go. Did that work? And if I do, oh yeah, pinning or spotlighting? Do you have a preference? What's the difference?
Whatever you did is what he was aiming for. This looks right now.
Cool.
Yeah, seems
great. Let's roll.
Okay, the problem that I'm going to try to present here is rather niche. It's about building software. This matters for open source software because when new people come and find a piece of code online on GitHub and they want to run it, it's typically hard. Typically, it's actually quite painful, especially if you're building stuff for the first time. You have to learn basically application-specific build system. Like most applications, they pick their own. There is CMake, there is Meson, there is GN. There are all sorts of Python-based systems. And if you include dependencies of applications, the situation is very messy. And building software, like especially if somebody new comes and wants to play with it, should be as easy and as fun as possible. So ideally, this should be a single command. And even this requirement, it already makes it super hard because there are actually very few shells or very few scripting systems that work across platforms, something that works reliably across Windows, Linux, macOS. And I mean, ideally, it would also work on mobile systems like Android and iOS. Sure, why not? And for a long time, this was not possible. For a couple of years, for the last maybe 5 to 10 years, I don't know exact dates, most systems started bundling Python. So Python seems to be this scripting environment which we can kind of expect to be present on every platform. Not the most recent version of Python, but some version of Python is probably there.
Quick question. When you say that Python is available on most systems, are you including like iOS and Android? And if so, in what kind of an environment are you thinking that this is going to run?
No, on desktop systems.
Desktop systems.
I will focus on desktop systems.
Okay.
It's more of an aspirational goal to, build stuff on Android.
That makes sense. Cool.
So if we have Python, we can write simple Python scripts that will build whatever we want. So I'm going to show you how Automat is being built. So the way to build Automat is to invoke Python, run the run.py script, specify a variant optionally, because without the variant it will work, and maybe some extra options that will make it more interesting.
Can you
one thing that happens?
Control plus in begin. Oh, if you go back to the terminal, if there's anything on the terminal, we're supposed to read in begin Control plus, bump up the font size. But yeah, it looks like we don't need to see the terminal.
We will have to see the browser.
Thank you. Yes, great.
So one thing that very few build systems do is they rarely expose any sort of documentation of the build. When you have a build described in a make file, it's described in a make file. And somebody who wants to learn how to edit build has to learn the syntax of make or CMake or whatever, or Meson or whatever build system you want to use. So one nice thing that a Python script can do is it can actually present a list of commands that are necessary, that have to be executed by the user in order to build a program. And when I'm saying that build graphs are pretty complex, this is actually the visual representation of the build graph of of this thing. So we can follow those links, and those are like specific steps that are necessary. Like we need to get depot tools. I don't know what depot tools are, but they are necessary to configure Skia. And then configuring Skia is a prerequisite for installing Skia. And we have a bunch of steps which are related to one another. Some of them can run in parallel, like in those many build systems. And by looking at this interactive visualization, we can actually see, for example, what commands are necessary to be executed. What is the environment that has to be set for this command to run? And yeah, we can see live documentation. So this helps with one of the issues that build systems often have, is that when some requirement fails, it's very hard to debug this. And if we have this huge graph, we can see which step in the build fails, and we can see how we should attempt to retry it, how to regenerate it, how to fix the arguments. Another thing which is nice of this in this kind of custom build systems that literally anybody can create because Python is universal, is that we can actually add some of the very much needed reactivity to standard compile, edit, compile, run cycle. When a script can watch the source directory, it can dynamically rerun the stuff that we are running, rerun the stuff that we are building. So here I have a small utility, and if I want to change, for example, the speed of the eye, right? The eye moves very quickly right now. I mean, you probably know how this live editing works. I can just change some number, save it, and the build system realizes that, hey, one of the sources has changed, rebuilds it, reruns it. The advantage of having a custom script is something actually nicer than most of these like automatic retries, because a custom script can also save the state and persist the state of the application. We can have our own custom fancy hooks here that will. Yeah, this doesn't seem to work. Yeah, now it works. So now we can see that the eye is moving much, much slower. It's much more creepy this way. So what else we can do? Another thing we can do is we can help with build maintenance. So a typical problem when we are maintaining a bigger project is that next to source files, we also have the build description, which describes how to build them. And if our sources are regular enough, we can actually build this graph automatically by scanning the sources. And this is actually how this whole graph is generated. There is no build description in all of Automat. It's all just source files, which are including other headers, which are including some important includes. And when the build system realizes, I will highlight the line, this, I can say install when included. And this makes the build system look for the include lines in a source file. And if any of the source files in my project includes this thing, it will pull the stuff from GitHub, configure it, build it, set it up so that it can be part of the build graph. And it even works nicely with different platforms. So I have some Linux specific kind of build steps in this graph, which are just unused because they are Linux specific and I'm on Windows right now. Yeah. So this is it. Custom build systems are fun. Strongly recommend.
I'm gonna second that. I am a big fan of writing your own build system instead of using something off the shelf. And so a lot of the benefits that you were outlining like really speak to me. That's been my experience
surprisingly
as well.
controversial. When you read opinions online, people tend to complain about custom build systems. I guess when this doesn't work, it tends to cause even more frustration than some well-documented, but also well-documented but unknown to the person build system.
Yeah. there's something about extending the area that you are kind of considering as part of your program. Like you have your main source code, you have your project, it does whatever it does, but you can kind of extend your thinking out to how that project is built and have some really interesting integration between the thing you're building and how you build it. That I think when you're not working in a live environment, when you're not working in a, you know, a REPL driven environment like you'd get with certain Lisps, say, having control over the build lets you do some things that recover some of the benefits that you would get if you were in a live environment. So like you said, about, you know, being able to persist the state of the running program and then bring that back at the, you know, when you're done building, that gives you a little bit of that live flavor, without having to take the plunge to, you know, being on that side of the spectrum.
Yeah, VMs are really they are causing a lot of envy when working with compiled languages, like VM that can persist state, that can do hot reload. All of those workarounds are just meant to bring the user experience of compiling to the same level as VM-based languages.
Any questions from anyone else?
Yeah, I've got a question. You built a build system for Automat with Python, but which libraries do you use or packages from Python? Or did you build everything yourself?
This is an excellent question. No libraries. You cannot use any libraries because there are no libraries that are like, except the batteries included part of Python that you can expect to be present across platforms. So even simple stuff like iNotify, like watching the file system, this is not part of standard Python. You have to essentially provide your own implementation, your own cross-platform implementation of even basic utilities. But the batteries included part is mostly good enough. You just have to fill a few small gaps to make it work.
Cool.
Yeah, that
How much
feels
time
similar
did it cost to build?
Oh, sorry.
How much time did it cost you to build this build system yourself?
I think probably a couple of weeks in total. I started building it like a couple of years ago, so it's hard to count. But for example, this web page that we're looking at right now, it was almost entirely vibe coded in like 2 days.
Just before we get to the end of the time, I just remembered you have to show us what the heck that eyeball UI component was. I don't think we've seen that before.
Pretty funny looking thing.
Yeah, what is this?
Oh, it's the eye again.
Yeah, what's the little crystal within the
Like spoil this.
Yeah. What is this, Marek? What even?
So this is a 4-dimensional shape known as tesseract, and that thing is a tesseract OCR, and I can run it maybe, so you can see how it works.
Oh my goodness! Because the OCR library is called Tesseract, so you built a visual tesseract as a way of working with it.
Yeah. So when we have a bitmap captured, I can like hook this up, and for example, I can run this in a loop. Yeah. So now it will. I mean, it broke, so it's not going to run. But yeah, this is the idea that it can. It uses a lot of metaphors. The eye is meant to signal that it's reading stuff. The hieroglyphs are signaling that, you know, it's actually reading some unknown script. And the eye, when it actually runs, it actually, you know, looks at the text that it's recognizing in real time.
Incredible.
And wait, what is this
Absolutely.
window? What does the program in this window do more generally? Just I've never seen it before. Like you're hooking things up. I don't know, which is cool.
This is meant for playing games. So if you're playing, I don't know, Diablo or something like that, and your health is running low, you can have OCR running in a loop to help you drink potions, for example, very quickly. It's a game
this
of
project.
nature.
Yeah, the project's called Automat, and it's something Marek's been working on for quite a long time and sharing updates in the Future of Coding Slack and elsewhere. So go look for Automat. Marek, do you have a like a URL for Automat that you want to plug if anybody's interested?
Yeah, it's automat.org.
Awesome. Yeah. It's an incredible website. Okay. That about brings us to the end of time. Marek, thank you. Very cool. Could not agree more. Build systems, build your own build systems. Good to do. Next up, Tom is going to show us a reactive something notebook. In previous virtual meetups, Tom has shared various experiments with Observable, and so I'm not surprised that we are once again going to see something notebooky, and I'm excited to see what this is. So yeah, whenever you're ready, Tom, go ahead.
Yep. Can you see my screen all right?
Yep, looks good.
Yeah.
Oh wait, do I have to unspotlight Marek? No, I don't have to. Okay, I think we're good. Yeah, I don't know why that worked.
Okay.
Great.
Yeah, so this is Lopecode, a project I've been working on for a while, and it's of interest to people who want to separate, remove that barrier between user and vendor, who want to write software that will always work without dependencies. And it's a reactive programming system, so it's interest of like live coding, literate programming, and data visualization. So the big idea of this is that it's a microkernel architecture. There's a runtime that runs in the browser, and it offers a few services, a data flow graph, so you can connect variables together reactively, and it also offers hot code reload. So any user space module is able to edit the code of anything else in the runtime, and that's it for the kernel. And then everything you see in this demo now is implemented in user space. So we can build a whole universe around that primitive. So within the runtime, there's many different modules. Modules are collections of variables, and they can depend on each other, which is what this data visualization is showing. As I say, it's reactive. So I can dynamically push a module into it, and that just clicked updated as, you know, this is a live view of the runtime state. And the point of visualization, we can see there's a lot of complexity in this module. It's hyperlinked.
Sorry, when you say push a module in, where's that module coming from? Is it like a file on your file system, or?
Yeah, no, this would get loaded from the Observable API. So it's ecosystem compatible with Observable, but it's taken that and injected it into the runtime. At that point, it becomes offline first as well. So yeah, so there was a network call there, and then we won't need to do a network call in the future. So the complex module I clicked there is the implementation of the editor, the thing that allows you to edit cells, and it's also live as well. So as I scroll through the network, we can see the editor understanding the cells I'm hovering over. There is no, like, the runtime is the source of truth, is the design. So there's no like external high-level source code. There's the low-level JavaScript that runs in the runtime. And then when we do need to work at the higher level code, it's dynamically decompiled on the fly. You edit the source code, and then it compiles it and pushes it back in. So the tool chain, the sort of reactive tool chain, is implemented in user space as well. We are looking at a web page. So this is a projection of program state to a bunch of DOM nodes. This visualizer is also implemented in user space. So we can programmatically even embed a visualizer working in a little area, even though we're also using it to render this whole thing. So the visualizer visualizes a single notebook, and then this whole, putting it all together into this like drag and drop thing. This is what I call a lope page, which is gives it that hypertext navigation and allows you to view multiple modules at the same time. Now, the runtime is
before you keep going. Another question. This is insane. This is super cool. Extremely meta, very hypertexty. I love it. where is stuff stored? You said there's no like canonical source code representation. You're decompiling things to get the source representation back out, which is really interesting, and I'd love to hear more about that. But I'm wondering, like, where, if I'm, you know, entering in code into this environment or loading data, like, are you just storing it in IndexedDB, or do you have some other kind of thing going on?
No, it's all in memory. Yeah, this is the next section, right? Yeah, it's all in memory. But because we have metaprogramming access over everything, it actually will inspect the source code and then serialize it. So I can now serialize the state of all the code to a single HTML file. So there I just cloned it to another in-memory version. Not only in memory, but I can also download it as a single HTML file, which is self-hosting. So that file has written down the code at that point. And so that's how we... So yeah, so that's how like it gets materialized at some point. But the program, the runtime is the source of truth, and the exporter is an adapter that gives it a serialization format. But you could write your own serialization format if you want. Not most of it is variables communicating as basically functions that are scheduled, but also you can attach binary assets as file attachments. So I use that for like assets like images, but also for JavaScript blobs, like this is golden layout. So it can take NPM dependencies and then vendor them into file attachments, so you can carry them around and that gets saved. But also these are editable as well.
Can I ask a question here?
Yeah.
You mentioned that this is saved to a single file. How do you save larger blobs? How do you manage those big dependencies?
Oh yeah, they're just base64 encoded and put in a script. So then yeah, so when you want to decode them, you just sort of decode the base64 representation. I think they might be gzipped as well for a bit of extra compression. But yeah,
so the script just gets very big.
Yeah. The one I just downloaded. So we can edit the things. So if we look at that one's 3 megs because I've stuffed a ton of stuff in. But when I serialized it, it remembered the state change there. So that was actually a binary save. So you can achieve that. It's got all this data visualization included. So this is an example of like linking a direct manipulation graph reactively to some numbers. You can do all kinds of things with metaprogramming. This is visualizing the state transitions of variables. It's an alternative representation of the program state, right, over time. So that's useful for debugging reactivity. I built this unit test debugger. So this searches for all cells beginning with test underscore and considers them a test, and they fail if it throws, right? And this is reactively linked. So you've got this hyper-fast unit test framework. And then the ultimate meta tool of all is, of course, we've got a user space agentic AI in there as well. So this thing, you know, you give it a list of tools and then it can start querying the runtime. And I haven't programmed much of like understanding of it, but it kind of just figures it out because it first starts by listing all the modules. Now it's listing the cells in the module. And I asked it to try and build a visualization. So it'll kind of like self-prompt itself. I would say that's a work in progress and it takes a little while to run. Yeah, so that's like the technical details. You can do all kinds of cool things, right? So if I unpause this debugger here, we've got audio stuff. And as I manipulate stuff, you see that shows up in the interactions there. If I just stop that. And yeah, that's a quick, fast-paced interaction. Oh, here's the AI. It generated a plot. Yeah, a rubbish plot, but there you go. It can do it.
So a question I have right off the bat is, I'm curious to hear your thoughts on the UI design in this environment. Like, it seems like you've got scrolling lists where there's blocks and each block can kind of refer to, I'm assuming, variables and other things exported from other blocks. But what would you do if you wanted to add some kind of a tool or something like that that would act across a whole bunch of other blocks or that would compose with them. Do you have any thoughts on that?
Well, I mean, like that debugger is one of those, right? It's scanning the whole runtime and giving you an alternative representation. Yeah, I've gone for the sort of notebook version that is very aesthetically similar to Observable, although it's got this multi-notebook thing going on. That's really just for familiarity, but you know, it's not the end game. Like the visualizer is in user space. If you want to have a different visualization, we could have a toggle, right? But I haven't got enough time to explore this. I wouldn't mind getting it into a VR environment. I think it will be great in that situation. And that's one reason why we got the AI, so you can like talk to it and let it code sort of without hands almost. But yeah, I mean, just first pass, make it familiar to people who understand Observable and give it that notebook format, because I think it's quite flexible and does the job. And it's easier, like it's easier for me to work on something where most of the design has already been completed and I'm not doing too many creative things at the same time. So it's a sort of compromise for now that we'll just do the notebook format for familiarity, and I don't have to think of too much CSS and all that.
Cool. Other questions, anyone?
Yeah, I've got a question. That debugger, that's included in the file that you export, that single HTML file.
Yeah, exactly. Everything.
Correctly?
Yeah, exactly. Yeah, the debug, like all those visualizations you thought are all booted off the same Grammar of Graphics plot toolkit. So it's incredibly flexible, that thing, and so it can give you this circular representation, this time series, even that thing with the gradients on. That's all plot. So it's a very flexible tool, and so there wasn't that much code to the debugger. Most of the heavy lifting's done by the plot visualization framework.
All right, cool.
We've got time for a couple more
Can we
questions
play?
if anybody else has any.
Yeah, one. Can we play with this ourselves? Is it
Oh yeah,
somewhere?
good point. Yeah, it's on like that demo is linked. It's going to be my proper introduction to the technology, and it's on the front of the GitHub called Lopecode. So if you search for Lopecode,
Yeah.
I don't think there's many things called that, so it's easy enough to find.
Yeah, thanks.
I have one question. It's about this thing like discoverability. Once you start a notebook, is there a way to kind of know like to search the library of potential functions that you can use? Like this observable library that you mentioned, that you can pull the modules from.
Yeah,
Is
I
it
think
somehow
like
searchable? Because this is something that when I look at a blank canvas, I would like to see what tools do I have available. You know, what can I build with it?
yeah, that was the idea of that module explorer at the beginning, and I'm upgrading that a lot, that it at least shows you the dependencies and you can at least see which ones are complicated, and you click them and then you're over there. Where I think like we're still working on is if you look at an individual cell. I didn't really show you the editing environment at all, but like it's sometimes hard to know how cells are connected together. So I want all this to be hyperlinked, so that you see something, you click it, and then it says that depends on this, this, and this, and allow you to explore the graph. And that's how the AI works. There's an explicit dependency graph, and it can follow the dependencies. So that's the nice thing about this data flow graph, is you've got quite a pure representation of that graph you had with your build tool, right? That representation is also in this thing, and I want to use hyperlinks to allow you to kind of explore that naturally. Yeah, there's no search. There's a search that the LLM uses, but I haven't exposed it to the human yet. But yeah,
you seem to know this observable kind of universe a little bit better. So there is probably like a website with a repository of modules or something like that. I guess it exists somewhere.
Well, yeah, you can import anything from Observable. So, I mean, Observable, the ecosystem is the codes I put in there are literally the URLs in the Observable notebook world. So if you find something on Observable or use the search or use the forum, and find something you like, it just goes straight into this as well. You can just do that dynamic import, and then it's inside that.
Cool. And totally, I have no idea about the observable universe and forums and this kind of stuff. Sounds interesting.
Yeah, Observable is really cool. It's worth checking out if you're not familiar with it. I'm gonna call time there. We're making great time today, so I'm gonna keep the momentum rolling. Tom, that was wild. Very cool. Thank you so much. All right, our last presentation for the day today is Achille, who's going to show a Chrome extension that I don't understand quite what it is, so I'm interested in learning about this.
Okay, so yeah, let me just share my screen and let's just make it more explicit. So yeah, so it all starts with like my stupid quest to just put my terminal inside of my browser. So why would I do that? Like it's for a simple reason, actually. It's because like everything is already running in my browser. So I have like, my Discord, Telegram, all of my apps are already just web apps. Even VS Code can run from inside the browser using like the VS Code server component. So in order to be able to work completely from there, there is only one thing missing, which is like a terminal, because like I'm a programmer and at some point I need to run shell commands to actually do stuff. And so, yeah, so I wrote a blog post like explaining my process, my ID and like how I did it. And I will not like go over it because I will just show it live to you, like why I do this. But at this point, like Tweety was running as a binary on your computer, starting a web server, and then you connected to the web server through your terminal using a local URL, a localhost URL. And yeah, so I posted this, and it got some like feedback on Lobster, which is an Hacker News alternative, and it was quite mixed. Like I love this one, well, that's cursed. And yeah, so people were intrigued, but also quite skeptical about my approach. And yeah, and so I decided to like actually just read all of those comments. And yeah, and I found another way to actually put a browser a terminal inside of my browser, which is using a Chrome extension and a super hidden and super undervalued Chrome extension API, which is native messaging. So native messaging allows a Chrome extension to access the underlying OS using like std in, std out. So the extension will actually spawn a binary on the OS, and you will be able to like communicate through there. And so yeah, let me just show you what I mean. So I'll just start Chrome because most of you must be more familiar with like we are all familiar with the Chrome UI. And so yeah, the basic idea is I put like a terminal everywhere I can inside of Chrome. So here I can have it inside of a pop-up. I can have it, I don't know, as a new tab. Or if I'm debugging something, maybe I want it inside of the Chrome DevTools. Or even, you know, I want to have, like, maybe there is not enough terminal here, so I'll just add another one, maybe as a side panel. So yeah, a bunch of terminal everywhere. But what's kind of cool about it is that here, so there is like a URL for my terminal. It's actually a Chrome extension URL, so it's not a regular URL. It's more secured than that. You cannot redirect your Chrome extension URL, for example, and there are a bunch of other security stuff benefits of using a Chrome extension. But yeah, one thing I can do with URL is, you know, for example, just run commands and have commands as part of the URL, and then bookmark them, you know, like have like a bookmark bar of my favorite commands. For example, if I want to like connect to one of my VPS, I can just like use the SSH command. And here I have like a bookmarkable terminal already like wired to my VPS where I run stuff. And then like IDs kept coming, and one thing I've realized is that I was able actually to just using the native messaging extension to actually proxy the extension API to Tweety. So here I'm in the Tweety terminal, and I can actually just access the Chrome extension API and manipulate my browser from the browser terminal, you know. So I can, for example, query all of my tabs, I don't know, and then manipulate them using GQ or any terminal tool, and do stuff with it. And that's super cool, because then I can just like wire the Chrome extension API to any shell tool. So for example, if we go to the Tweety homepage here, and I want, I don't know, like to get like a summarized version of the README, I can just use one of the features of Tweety, which is the ability to register custom commands to the Tweety binary. And here I have, for example, a summarize command, which will use the Tweety tabs print command to print the HTML of the current page, then pipe this HTML to HTML to Markdown CLI, and then I will use mods, which is like a OpenAI wrapper to actually summarize the tab. And so here I can either type it or just run Tweety summarize, and yeah, it gives me like a summary of the website. So it's basically like a Chrome extension. This little script of one line, it replaces for me a Chrome extension. One other thing that I always want to do is I'm on a blog. Let's use my blog as an example, and I want to extract the RSS feeds because there is no button in the native UI to actually detect it. And sometimes people put them in the head bar. Sometimes you need to go to the about page. Like it's a bit messy. And so here I have a command, Tweety extract RSS feed, which just gives me the RSS feed. And then I can just like pipe it to my clipboard and access it. So I have like this super low effort way of extending my browser, building like managing tabs, doing stuff with it.
That's really interesting. Like this is, I'm looking at this and I'm thinking, okay, so it's kind of like a meta extension. So within this extension, you can script the browser and add behaviors and augment what the browser already gives you. It's sort of like an inversion of the usual relationship between the browser and the terminal that I'm used to as a web developer, where I'm used to in the terminal, I'll run, I'll spin up a server, a local development server, and then launch the browser. And it's sort of like the server is kind of like the thing that the browser is resting on, but you've flipped that relationship around now, which is interesting and generative. And it makes me wonder, like, what if we're used to thinking of the terminal as something that lives inside our OS, right? Like we have the shell that's on Unix and use it to work with the file system and run programs, run binaries in that environment. But when the terminal has come into the browser, it makes me wonder, like, what kinds of things could you do with the browser and the network and the DOM and all of that as your substrate? And I imagine it's like all the stuff that you could do with JavaScript, because we already have a console in the dev tools. But I bet there's like entire new classes of things that you could do because you have such a more expressive terminal that's also like bridged out to your OS. So yeah, really interesting project.
Yeah, I'm still playing with it. I'm still finding like new use case. So for example, I would love to actually have the ability to extend the context menu of like with shell script. So for example, maybe I want to just select something, then like from the context menu here, I have a way to trigger a shell script which does something and maybe open a new tab or do stuff like that. But yeah, it's kind of weird how tricky it is currently to just create a Chrome extension, how messy, like how intuitive it feels. Like you need to endlessly compile, not compile stuff, but like it's clunky. It's so much effort to do even basic stuff. And yeah, like since I've bridged the shell and my browser, I've built like multiple extensions because it's so quick, so easy, so it's yeah, super useful.
Yeah, you suddenly get compositional things and pipe, which is, you know, a superpower.
I've talked about Chrome a lot, but actually now Tweety also works on Firefox. So yeah, it's a web extension and not a Chrome extension. I'm just like, it's not on the Chrome store yet because I'm quite worried about the Chrome review process, and I'm not sure like building an alternative extension API is something they want on their store, but I'll try it anyway at some point. It's just like I need to give them $10 of my pocket to actually apply to the review process. I'm not super hopeful, to be honest.
Yeah, sounds like the kind of thing where they'll see that and they'll come to your house and take your computer away. That's the reaction they might have.
Yeah, they might.
We've got a couple minutes left. Any questions from anyone else on the call?
I do have a question. You mentioned this native messaging API. I wonder, does it work on, I mean, you showed the SSH example, and I'm starting to think like, can this work on mobile somehow? Because, you know, regular computers that we kind of have on our desks have very little, you know, we only have access to them when we are at our desks. And the ones we now, you know, in our pockets, we have all the time with us. They have access to our location sensors, audio very easily. I mean, does this native messaging, could it work on mobile? On like, could I like open my phone and have a very cheap, very fast to write, you know, way to script my phone? Because my phone it's an Android device. It's such a pain to write apps for this.
Yeah, so the bad news is basically like Chrome extension do not really work on phone. There are some browser like the Kiwi browser on Android which support like Chrome extension, but I doubt that they support something as
so I'm using Firefox, and I'm I am a user of eBrock Origin. I use this all the time.
Yeah, it's true. I don't think the native messaging API works on like I never saw like while browsing the native messaging docs mention of Android or iOS, but yeah, it will be fun. Like I'm also like super interested in doing stuff from my phone. Like one of my other project, one of the goal was actually to be able to just do just quickly edit a website and stuff like that from my phone. Tweety is not there yet, but that will be fun.
Yeah, we are hamstrung by web standards.
Yeah, I have a question as well. So yeah, there's so many limitations in the browser, like cores being the annoying, obvious one. Is actual web pages able to script Tweety? Can you somehow like, you know, use it to proxy, you know, a TCP socket or something? Like, can you extend the user space apps as well?
Kind of. So for example, if I go to, I don't know, github.com, for example, and I want to access, so let's say I'm signed in and I want to access my data, but this data is protected behind, cookies or stuff like that. I can just use the Tweety fetch command, and it will run the fetch from the browser. And so it will like benefit from the cookie from your browser session. Like, so it like Tweety has some access to browser level stuff. But the other way around, for security reason, I don't allow websites to I don't know, like ask or even to
Oh,
communicate with Tweety.
Come on. How bad could it be? Expose an API to a
Yeah.
shell, to JavaScript, so that any JavaScript can
Yeah,
say,
it's true.
hey,
Maybe I should inject, inside like a Tweety a variable window.tweety or something.
yes, exactly.
And yeah, and then
yes.
allow it to run shell commands and will no, but yeah,
Yeah.
it's true. It's true that there is so much API surface in the extension API, so much interesting thing there, and yeah, like it's a shame that all of this is buried between like all of this friction and but yeah, okay, I'll promise I'll explore a bit like this website to shell communication, and then folks from Lobster will be angry again, and but yeah, okay, deal.
That's I think a great note to end on. Banger demos today, y'all. Very, very good session. That was a lot of fun. Thanks for preparing and for sharing what you're working on. And thanks to everybody who came out in the audience. That was a fun one.